Hello, welcome to our latest webinar on restoration. So we're going to get into a little bit of how to do restoration, why it's important, and just making the most of BC's local ecosystems. So my name is Jamie and I'm here with my partner Alexa, and we're going to be taking you through a little bit about restoration today.
Okay, so before we begin, of course, we'd like to recognize the really diverse history of Esquimalt Gorge Park. So Esquimalt Gorge Park has had a really diverse history through time. So the park is actually part of the traditional and unceded territories of the Lekwungen-speaking peoples, today known as the Songhees and Esquimalt First Nations. So they, with other First Nations groups, such as the Suk and Saanich peoples, have deep historical and current relationships with the land that continue to this day. Prior to European settlement, the Lekwungen peoples used Gorge Waterway for fishing, hunting, and travel. So Gorge Waterway was referred to as Kemosak. And we have provided a link here, as well as an email reach out if you'd like to learn more about the Lekwungen speaking peoples, their history, their culture, and the important work that they do today.
Okay, so if you haven't heard about them before, GWAS is a charity organization focused on education and environmental stewardship in and around the Gorge Waterway. So the primary hub of GWAS is the Gorge Waterway Nature House. It serves as the primary focal point to both the Esquimalt Gorge Park and to the mission of GWAS. So GWAS participates actively to contribute to the health of the Esquimalt Gorge Park and of the Gorge Waterway in its entirety, and that of the community that surrounds the park through community events, cleanups, restoration, volunteer, and youth involvement. Alexa and myself are part of the YCP program, which is the Youth Community Partnership Program. It allows young professionals such as ourselves to gain valuable experience under the supervision of skilled professionals such as the beautiful people we've met at GWAS. With its valued partners such as World Fisheries Trust, the Gorge Waterway Initiative, and some municipal groups, GWAS has maintained a holistic, determined, and steadfast commitment to the health of the Esquimalt Gorge Park and of its community.
Okay, so a little bit of background into the area. When we talk about EGP, we essentially just mean Esquimalt Gorge Park, just an acronym. So within EGP, there is a creek called Gorge Creek. It's a 1.5-kilometer stream that actually drains over a 217 hectare area watershed into Gorge Waterway. So this is about a third of the city of Esquimalt, which is pretty impressive. So in the early 2000s, it became apparent that some of the historical connections to Esquimalt, or some of the historical uses of Esquimalt Gorge Park, had actually damaged it quite significantly. So with the onset of European settlement came decades of industrial, recreational, and urban impact and pollution. So when this became very evident, there was a call to basically restore this area to its previous ecological cornerstone. So past uses included a tidal swimming pool, diving facilities, an amusement park, tennis courts, bathhouses, estates. So all sorts of things that really degraded the area and really made this restoration pretty important. So this enabled the daylighting of the Creek Restoration Project, as well as Gorge Waterway Initiative, and of course, Gorge Waterway Action Society itself.
All right, so now we're going to get a little bit more into it. So what is restoration and what is environmental degradation? So we know that the impact humans have had on the earth and its natural rhythms is pretty much immeasurable. But restoration is one method by which people are aiming to mitigate this impact. So it's basically the effort to return a natural landscape to one that more closely resembles the biophysical composition prior to human intervention. An important quality to note, especially nowadays, when we're thinking about our Gorge Creek system here in our own backyard, is that coastal wetlands are actually one of the most threatened ecosystems on the entire planet. So restorations of sites like the Gorge Creek is at a critical stage. And environmental degradation is when natural spaces are damaged or eliminated, whether it's through pollution, deforestation, climate change, loss of diversity, and all sorts of other reasons. But the causes for this degradation can include urbanization, population growth, economic growth, agriculture, transportation, and pretty much anything you can think of. While the majority of this degradation is human-derived, there's also natural processes that do degrade environments, such as fire, hurricanes, landslides, and other natural disasters. The majority of restoration research appears to be skewed to North American sites, so that's important to keep in mind as we go through here. One major way that the environment can become degraded is by the exhaustion of resources in the area. So this is one of the major ways that, in particular, invasive species cause environmental degradation. So if an area had enough resources to support a booming invasive population, as well as the native species in the area, the presence of those invasive species is not going to be as much of an issue. But it is a key trait of the invasive species that they are able to proliferate to a point that the native species can no longer compete with them for the resources, resulting in the native species experiencing stress or even extinction. Environments can also become exhausted of resources due to fragmentation. So in the development of urban infrastructure, it's resulted in natural ecosystems being limited to small sections of land, often fairly isolated from one another, which puts a high pressure on the system to maintain that population within it. And the numbers in this population actually become greater due to the lack of available habitat. So we've made these little islands of nature and forced a high population into it, resulting in high competition and a high probability for that resource exhaustion. So why do we want to do restoration? Why is it important? So the earth and nature are going to eventually reclaim what we've created, and given the space and time, the ecosystems would recover on their own without intervention. So why do we want to do it? It's basically, it just speeds up that process of environmental recovery. That timeline, without intervention, there's no way we could know of it. And it's often unrealistic to expect that an ecosystem would be able to remain untouched without any interference by humans, or any human impact for the amount of time that the ecosystem would need to truly recover. So with our restoration efforts, we can try and restore the environment in a faster timeline than without. One of the main things that we're trying to bring back to an ecosystem are ecosystem services. These are basically benefits that people get from ecosystems. So examples include carbon storage, climate maintenance, and controlling water flow. And a lot of our restoration occurs in urban areas because these are ecosystems that are most frequently impacted by human activity. Some of the ecosystem services provided by these urban natural areas include mitigating a bit of that urban heat island effect. It's where an urban area becomes a lot hotter because there's not as much heat dispersing elements to it. It also can lessen the load of urban drainage systems, improve air quality, and also has a significant impact on human mental and physical health. Another benefit of restoration is generally an increase in biodiversity, which can enable an ecosystem to become healthier and more resilient. If you increase the biodiversity of a site, it increases that resilience due to the interaction between the organisms. So each organism comes with its own capacity for dealing with stress. And if you do have this diverse composition, each organism is going to be able to contribute to overall ecosystem resilience.
Okay, so when we're deciding how to restore a site, there are obviously a lot of considerations to be had. Restoration is a very large topic. When we're looking at restoration, specifically here in BC, the BC government has actually separated both terrestrial and aquatic systems. It's made them separate. So when you're looking to do a large scale restoration project, you can actually see the priorities within each of these two systems. They're ranked amongst themselves. When you're also considering a restoration site, there are other considerations to be had, for example, land ownership, and we'll go through kind of more of an extensive list shortly here. What's interesting, when they grouped aquatic systems, they mentioned high priority watersheds and subwatersheds, but they did not include wetlands and lakes, lakes such as kettle lakes. So generally, this is because all wetlands are considered high risk and high potential for restoration activities. They're very integral. They provide us a lot of ecosystem services and have a high degree of biodiversity. Those kettle lakes that I just mentioned, they're often great sites for restoration because they're often impacted heavily by agriculture and other human effects, and they also hold high biodiversity. So in these terrestrial systems, the government categorized these sites into BEC zones. BEC basically is an acronym that stands for Biogeoclimatic Ecosystem Classification. BECs are basically a way to categorize different ecosystem types based on their vegetation, their climate, soil, geology, and also their placement on a successional scale. successional scale, essentially meaning how far along the ecosystem is from a very basic level. So at your more basic successional stages, you're going to have younger, more simple ecosystem assemblages, whether, or rather, as you go higher up into the successional scale, you're going to have a little bit more resilience, a little bit more complexity, some longer lived species. Understanding what BEC zone you're in can help you understand your ideal outcome for a restoration project. For example, in the EGP, we are within the coastal Douglas fir BEC zone. This is categorized by large population of those Douglas fir trees. We also have mild wet winters and relatively dry summers. In your info pack, if you do live here in BC, you can actually check what BEC zone you are in, which is quite interesting. Okay, so a little bit more of those considerations that you have to remember when you're choosing a restoration site. When deciding what site to choose for a restoration project, there are both environmental and cultural considerations you have to keep in mind prior to confirming your site and actually going through your planning steps. Most of these considerations are quite high scale for high scale restoration, large scale restoration projects. However, they can be slightly compared to your own backyard, for example. So all of these considerations help the restorationist to decide what is the most logical, the most sound, effective, and cost-friendly option for the desired outcome or ecosystem. The environmental foundations, a few examples. We've chosen specifically to look at a wetland example just because it's so applicable to EGP and also to so many wetlands in BC. So for example, when we're looking at a wetland site, we can look at past drainage. Areas with past drainage can often represent historic wetlands and they're great potential restoration sites. So coming from a historical wetland, creating another wetland in a current state is a lot easier than creating an entirely new wetland. Even proximity to other wetlands, parks, wildlife areas, this can create connectedness within sites that wasn't there before. Cultural considerations that we can look at. Of course, I mentioned land ownership. That's obviously very important. Public land tends to present lower costs than private land does in terms of restoration. We can also look at pollution and other watershed problems. So these sites may be high priority, but they also might be high risk because they're susceptible to so much pollution and so much degradation. One of the most important things to remember before you are executing a restoration project is to speak to First Nations groups because they may often have projects or ideas that are already underway in terms of restoration for the site, and they can also share critical insight with restorationists. Other groups you might want to consider include local industries, environmental and civic groups, academics, funding agencies, or any other legal bodies that would need a consult in the decision. From this point, your planning will take over, which will look at your ecosystem classification and any disturbances. You'll start to review literature and data, archives, maps, historic and current land use, and just checking out similar projects and surveys, getting essentially your planning steps underway.
All right, yeah. So when you're developing all these goals for your restoration site, you want to determine, a potential outcome for your project. We're going to call that your desired future condition. I might call it DFC. So sometimes your desired future condition is to restore an ecosystem to what it used to be, but sometimes it's just going to be changing the ecosystem into something that's sustainable within a modern context. And to determine your desired future condition, it's often useful to use like a reference ecosystem. So there's two types of these. You've got a contemporary and a historical reference. A contemporary reference site is an existing parcel of land which has experienced, minimal disturbance and can be used as a reference to what you're working on based on its similarity to what you're working on. The benefit of that contemporary reference is that you can see how it's functioning in a modern time with modern effects, but they're often pretty small parcels of land and they have usually been subject to some amount of disturbance through time, so they're not perfect. Whereas a historical reference site, it's a bit better for showing how an ecosystem might have functioned in the past before this disturbance. So the goal is to get information from before significant European influence, which in BC means between 1600 and 1880-ish. Historical reference, it does require a lot more research, and you got to dig deep into those historical archives for, First Nations accounts and early research. Interestingly, trees can be pretty useful in providing historical reference, is they got a lot of information in those tree rings for someone who knows what they're looking for. So once you've established your desired future condition, now you're really starting to plan this project. So outlined by Hobbs and Norton in 96 is your kind of the main procedures you want to follow. So step one, you want to figure out why the ecosystem is or has been degraded. If you can't figure out why that ecosystem is being degraded, it's probably going to be difficult to determine an effective way to either limit or improve that situation. Number two, you want to define a restoration goal that's achievable based on that desired outcome. So determine whether that goal is, lessening the extent of future degradation, maybe eliminating future degradation, or even just enhancing or restoring the ecosystem. Number three, you want to develop that prescription to achieve those goals that's specific to your problem and ecosystem. So based on what you determine to be the problem and the classifications of your ecosystem, what steps are reasonable and achievable to improve the situation? Number four, you want to identify key monitorable aspects of the project and how to measure those changes. So this is how you're going to measure success. For your small scale projects, maybe you're just going to use something as simple as like a visual cue. There might be less English IV, and that's your measurement. Number five, you're going to implement it. So that procedure you put in place, go do it. Number six, you're going to monitor your progress. So using those same monitorable aspects that you outlined prior to implementing that procedure, you want to compare to your baseline measurements. And then number seven is usually just maintaining that progress. So it's unlikely to be a one and done procedure. A project requires maintenance, and often the reasons for the system degradation are still present in some amount. And it's going to require continued monitoring and further restorative actions in order to maintain your initial efforts.
So as we've mentioned, in order to really have your clear success, you do have to have these goals and objectives quite well thought out prior to even completing your restoration project. So these can be simple. They don't have to be as complex as we see in large scale restoration projects. This chart is quite complex. So you can see that there's a large goal and there are several objectives to accomplish this goal. But it can be simple. It can be something as simple as I want less invasive species in my yard to create a more resilient ecosystem. And your objectives could just be to perform invasive species removal and planting native species, for example, at certain intervals or certain times to accomplish your goal. So this framework can be applied to small scale personal restoration too. Okay, so we'll give everyone a chance to think of some local invasive species that may come to mind. We're going to highlight a few in detail right now. So, okay. Okay, so reflecting on one of the most common invasive species, probably one of the most easily recognizable as well. Probably many of you have heard of English ivy before. English ivy is a vine-like plant. It can be identified by these dark green waxy leaves, and it tends to climb and grow quite aggressively above the ground, as well as even onto trees. The leaves actually exude a glue-like substance, which helps it to climb so well, and it is a perennial, and it's also extremely tough and hardy. So a couple of factors that make it a really tough invasive species to get rid of. One of the reasons why it's such a problem is it actually can outcompete trees for access to sunlight by climbing over its branches and leaves and preventing the leaves from being able to photosynthesize and thus grow. It can actually slowly kill a tree this way. So how to remove this English ivy? It's actually quite doable for the beginner restorationist. You'll always want to be wearing your protective clothing and gloves, especially because this oil can irritate your skin. And whenever you're dealing with other invasive species, some of them can also have harmful properties that you want to protect yourself from. So in your info pack, there are some very detailed instructions how to go about removing English ivy completely and properly. I'll just go through some very basic steps. Essentially, you're going to want to collect ivy on the ground, collect your first portion of it, and slowly roll it along the ground until you can't roll it anymore. Once you find that root connection that you can't get past, you're going to want to sever the leaves and the vine from the root connections, and just keep doing this over and over again. Try not to leave any portions of the plant behind, especially leaves, because they can actually help the plant to regrow again. If the plant is growing on a tree, you can cut the base of the ivy and slowly pull it downward, but being careful not to damage the bark too much. And again, you're going to need to do regular maintenance on this, probably for at least every several weeks.
All right, there's another one that we probably all recognize. We've got the Himalayan Blackberry. It's a pretty significant invasive species in BC. Grows super dense and it can choke out other species in an area and also restrict animal movement. We do have a native blackberry, that's the trailing blackberry, and you can tell the difference because the trailing blackberry has only 3 leaves per stem, whereas the Himalayan has 5. And the trailing blackberry, the stems are a little bit more of a blue-green, and they're generally closer to the ground as well. So when you want to get rid of these Himalayan blackberries, you generally want to go on a day, in the fall or winter when the species is dormant. And you basically just want to start by cutting back all the growth that's above ground. So removing as much of that bulk as possible. And then once you've got the majority of that bulk, if it's doable, for the ecosystem that you've determined, it's not going to be too damaging, then you want to remove those root balls. So those can be pretty big and pretty well established. So sometimes you can do it by hand, using just hand tools. But, if your project determines, or you've determined and you have the budget for it, some people have opted to use even a backhoe to just really make sure that the bulk of that root crown is out of the ground, because otherwise they will come back and it will require more maintenance. And then we've also got Daphne Laurel. So it's probably a familiar face, but it was initially popular as an ornamental plant because it's got pretty fragrant flowers and really pretty leaves. But it's successful in a broad range of habitat types, and it grows pretty densely. And also birds really like its seeds too, so it's spread very easy. One note about this one, this plant's actually poisonous and it produces noxious fumes and skin irritants when cut. So your protective equipment's super important when you're removing it. For removal of this one, generally, if it's a damp day and you've got small growth, you can pull them up, just the entire plant, get roots and all. But if you have a bigger plant and it's not doable, then you just want to get as far below that soil level as you can and just snip it off there. Yeah, really important with these ones, not to transport the plant material in a closed vehicle, because those noxious fumes will continue to be produced, and you don't want to be in an enclosed area with it. But for all of these species, you want to first assess your site for the most effective removal. Usually in a smaller patch, that means working from the outer edge towards the center. You want to make sure you have a method for collecting and properly disposing of those removed materials. And it's also recommended in all cases to plant a native species. It's just going to help maintain that invasive removal if they have to compete. And it'll also kind of restore the area by reintroducing those native species. So initial detection and rapid response is the best strategy here for combating invasives. And we've also got a good list of species to plant instead of invasive species in your info pack.
Okay, so again, moving to a little bit more of a general topic, coming from specific again to a little bit larger. So some of you probably have heard of Garry Oak ecosystems, especially if you live here in BC. Garry Oak ecosystems are one of the rarest ecosystems in British Columbia. They've had a drastic amount, but they do have a drastic amount of ecosystem significance. So since the onset of European settlement, they've actually seen about a 95% decrease, so very, very significant. They're within that coastal Douglas fir BEC zone. Remember that we discussed with those certain characteristics. So Garry Oak ecosystems are very high priority for protection. Generally, a naturally occurring Garry Oak ecosystem is known to have naturally occurring garryoak trees. They can be found in areas such as on coastal bluffs, maritime meadows, vernal pools, grasslands, rocky outcroppings. So quite a diverse selection of habitats. Unfortunately, things like habitat loss, fragmentation, and degradation have all contributed to this 95% decrease in garryoak systems. So the most important thing, one of the most important things to remember about garryoak ecosystems is that they support a really high population of associated species. So they actually support about 100 other species. These species depend on these very important garryoak ecosystems. They have obviously have evolved to grow with these trees and with each other. So in order to keep these species alive and to keep these garryoak ecosystems, obviously hopefully successful going into the future, there are a couple of procedures that we can do for the associated species. Salvaging and propagation are two of the most common. So there's a very extensive list in your info pack that goes through really how to salvage and or propagate each of these 100 associated species. Obviously, we don't have the time to go into all of them, but it is possible, and each species procedure is a little bit unique and a little bit different. So if you are interested in supporting those other species, your full directions can be found in your info packets. Okay, so moving on to Esquimalt Gorge Park, getting a little bit more relevant to the work of GWAS. So we're going to go through a large-scale restoration project here in EGP, as well as a small-scale restoration project. So I mentioned very briefly at the beginning the Gorge Creek Restoration Project. So here in EGP, it is an example of a large-scale project, and it will actually require decades of monitoring following the time that it's been in action. So a 400-meter section of the creek was previously run through an underground storm drain to allow the top portion available for recreational activities. So in order to return this to a more natural watershed system, the creek was actually brought to ground level. This obviously required a lot of structural adaptations and a lot of resources and planning. So it now functions as a tidal marsh area, and the creek can actually have has the capability to filter water before that water enters the gorge waterway. Like I mentioned, it can drain about a third of Esquimalt, which is pretty impressive. So the main objectives were increasing biodiversity, improving water quality. So these are two measurable qualities, and the success of the project is still being monitored. So like we've been saying, nothing is ever a one and done event. Essentially, the amount of suspended solids in the outflows and the species diversity in the park is being looked at. So it's important to remember that even though structural adaptations may be made, we have to be very holistic in our restoration. We have to look at chemical and also biological indicators and factors that play into a restoration project. An example of a smaller scale restoration project is the forest area here behind the nature house. When you walk through, you might notice that there are lower numbers of invasive species now. This is due to the hard work of our restoration coordinator, Steph Gurney, as well as lots of community members, many of them volunteers that have cooperated to remove much of this invasive matter. The forest had previously been overrun by both Daphne Laurel and English ivy. So a couple of examples here, but regarding EGP. Before we move on, I want to bring in the watershed connection. So for those of you that don't know what a watershed is, it's essentially a large system that drains water, either surface water or groundwater, into a more common source like a creek or a lake or an ocean. So when we're talking about the structural adaptations, like I said, they're important, as well as those biological and those chemical means. So in order to keep our watersheds healthy, we have to look at all of these qualities. We can't just look at one and keep going forward with that. We have to really include everything. And right now our biology stream is working hard to get that water quality data that I mentioned.
We've also got a lot going on in our new pollinator meadow. So this was put in at the end of last summer, planted with a bunch of native species, trying to bring in just more native pollinators. So we're going to see what our restoration crew is up to in there.
Okay, so this is our restorationist Grinch. He's going to be talking about restoration and biodiversity in the meadow.
meadow here, so yeah, we're just pulling the grasses and things from there.
Awesome.
It's important because getting rid of invasive species can help native species grow, and that then increases biodiversity, especially insect biodiversity, which can help bird biodiversity, like purple martins, for example. So yeah, it's all just important to basically the general idea is increasing biodiversity. Going deep in, and then I'm trying to just loosen the soil up a bit, like the roots, until I can actually get a firm grip on it, and then I pull it out.
Awesome.
Yeah. But yeah, it's very, very, you gotta be very careful, because like obviously the root system is near the other plant, but yeah, just being really careful. It's also hard because all the snow, the soil is a lot more compacted and saturated. There you go.
All right, yeah, so that's just a little bit of the work that's going on in that pollinator meadow.
Going deep in, and then
You can see they're picking out which invasive grasses they want to remove and making sure not to disturb any of those native species while they're doing it.
Nice little mud hole for some insects.
Mm.
And here we have just a nice collection of some of those invasive grasses and weeds. Again, you don't want to be leaving that material behind in case of possible regrowth. Just collecting that material and disposing of them as per your municipality's guidelines.
Yeah, so you can see this was our crew. We got to go out and remove a little bit of English ivy. Yeah, we're going to take you a bit through that and come join us virtually.
So this is sort of our before image. You can see how much covered there is with ivy. And here we can see Jamie following that rolling motion of collecting the English ivy. So she's at the end and she's got that nice little bundle. So you keep rolling it until she can't anymore at that root junction, and then just cutting as close as you can to that root junction along the soil, and then you'll get that nice little bundle.
Oh, I think we missed this one. This is removing Daphne Laurel. So Alexa's going to show us how she took that out without, knocking herself out with noxious fumes.
So trying to not disturb the soil significantly, but still trying to loosen the root systems of that plant. If you cannot pull the Daphne Laurel out without disturbing the soil significantly, you're just going to want to cut as close as you can to the root systems. It might be slightly under the soil, that line that you cut.
Yeah, if we start disturbing soil too much, we're creating good habitat for those invasives to come right back in. So just minimizing their access to, land is basically why we want to minimize our soil disturbance. So yeah, you can see we collected a good old-fashioned pile of weeds. And there you go. There's our after. So, this was just a couple hours. It doesn't take too long. But with a little bit of elbow grease and a team, you can really make a big difference.
Okay, so whether we're looking at a large or a small scale restoration project, why is knowing success important? Why does it matter if we did something right? If we complete a restoration, why isn't that enough? So when we're speaking about large scale projects, for example, an entire forest habitat or a creek, there are several points generally used in assessment to determine success, and success is important here because there are several interest groups that are concerned with the success of a project. So these can include resource agencies, that need to know how much of their communities are being restored, regulatory agencies that need to see if projects have been fulfilled. For example, has a mining site been compliant in their restoration? Restoration ecologists want to know if their techniques worked. They want to know if they can use these techniques elsewhere. We want to be able to justify a restoration activity. So if we created a really healthy functioning ecosystem with lots of biodiversity and lots of success, we want to be able to essentially be proud of that and encourage it elsewhere. And improving our best practices, seeing what works, seeing what doesn't. Obviously, we don't want to be performing a practice that simply does not work. So the success of a restoration project cannot always be measured in the same way, and these goals and objectives have to be specific to each site. So you have to have these clear goals and objectives to really gauge your success. You also have to have a time frame that they might be reached in at pre-restoration, so not after your restoration has been done. So how do we gauge success? There's something called indicators that restorationists like to use. An indicator is a monitoring metric, not to be confused with indicator species, which is kind of a different topic. An indicator can be something that relates to your goals and objectives and will help you determine restoration success if used properly. They're often called ecological or ecosystem attributes, and they can direct scientists towards information about the environment. Again, you want to be quite specific and tailored to your own local ecosystem. An example of an indicator could be organic soil content or species richness. Even with these indicators, we do have a lot of uncertainty with how effective restoration projects might be, and what makes them success or failure can still be vague, no matter how informed we go into the project. And it is quite difficult to gauge success or failure, especially within a short time frame. Failure is arguably easier to describe, and it can occur when a restoration project has a poor idea of ecology, poor described objectives, unforeseen problems, no gathering of data post-restoration, no supervision. The list goes on. Sometimes even if you do everything right, even if you do look at your ecology, you do follow up with your data, things can go wrong, and sometimes problems come up and restoration projects do unfortunately fail. So failure can be confounding too. Projects might work for some time, they might deteriorate later. The only way to find out if a project is going to be successful, obviously coming in with our research too, but is just to implement it. And then you can see.
Yeah, so as Alexa's saying, monitoring's an important factor to determine the effectiveness of your protocol and determine your next steps in your maintenance too. So if you monitor your project closely, you're usually going to learn new insights about that ecosystem you didn't know before. So you might learn what you initially implemented as your plan might not have been the best method for that system in particular. So we often don't know as much about a stagnant ecosystem as we can about one that's responding to change. So the way that system responds to the change usually informs you a bit more. Good quality monitoring can also allow you to change your goals for your future projects so that they better suit either that system or another one. And the measuring of that success depends on that goal. So if you wanted to improve habitat for maybe a threatened or endangered species, monitoring the population of that species in the area might be a good effectiveness gauge. You know, for a lot of projects that might be smaller and simpler, effectiveness monitoring might just look like, did my removal of this invasive species contribute to its lowered prevalence in that area, whether that's short-term or long-term? A widely accepted notion for success is when the resource system very closely resembles a similar and naturally regenerating system in terms of structure, function, and resilience, or when the compliance of the project goals are reached. So generally, an assessment of a restoration will include looking at the ecosystem's function and structure, as well as connections between the restoration's actions and the response in the environment.
Okay, so how do we go about restoration personally in our own backyards, in our own little ecosystems? So all of this information, it does include large scale restoration, but it also is applicable to our small scale restoration projects. As we've mentioned lots, reintroducing native species will help restore your land in any size parcel, in a backyard, in a garden, in a patio, in a large acreage, anything makes a difference, and it will make good habitat for increasing biodiversity. So BC Invasives actually has a whole guide on what native plants to put in place of your invasive species that you might remove. This is included in your info pack. A couple of other notes in really creating a healthy, functioning, restored ecosystem. When we're looking at a pristine ecosystem, it's likely going to be full of natural textures such as boulders or decaying logs, especially in something like a forest. So adding textures in your own backyards, depending on whether or not, of course, they would naturally occur, can encourage habitat for different species, insects, small creatures. So this can further increase the biodiversity of a space. If you do have lots of flowering plants already, that's great, but do consider adding elements that support a variety of local pollinators. For example, mud puddles for butterflies. We kind of saw an example of that in the pollinator meadow. Mason bee homes, they are a local pollinator. Obviously, honeybees do great things, but they just don't have the adaptability that our local pollinators do, like a mason bee. If you can, resist the temptation to let your manicured lawn or resist the temptation to cut your manicured lawn. Allow it to grow and plant a variety of vegetation types. So typically, usually we don't want a monolith of grasses. It's usually good to have a diversity in most systems. And this will also reduce the amount of mowing and watering you have to do, saving you money and maintenance in your yard, which is great, and provide a dynamic habitat for a variety of species. Having a good source of water, having a pond is good, but there is quite a bit of maintenance required in order to prevent mosquito infestation. So a bird bath or that mud puddle are really great first steps to do in most cases that don't require as much maintenance. Letting your leaf litter lie is a really good idea. Leaf litter is a great source of nutrients for your soil, and allowing it to stay will give that soil the nutrients that has, obviously previously been removed from it. So giving your garden or your lawn a good mulch, giving your garden a good mulch, it will help decomposers to break down any organic matter, improve your soil quality, and provide home for other critters to lay their eggs and to even hibernate over the winter. Obviously, this is quite an obvious process, but staying away from non-natural herbicides, fertilizers, pesticides, insecticides, these can leach into the soil. They can have unintended consequences, affect unintended species, and they can actually eventually find their way to us through our water systems. There are many natural and non-invasive methods of pest control that you can find as an alternative. Creating your own compost. This will save you money on non-natural fertilizers and again return that organic content to the soil. And then you're also sustainably dealing with your own scraps. So it just creates a really holistic balancing system in your own backyard.
All right. Thank you all for coming out and listening to us chat about something we care about. If you have any more questions, feedback, or if you want to just share, maybe a little restoration project you've worked on your own, feel free to share that with us. You can email us at gorgewaterway@gmail.com. I believe that's it. And also, we want to make sure that we've got a little scavenger hunt going on in the park. If you've ever used the app iNaturalist, go out, tag yourself some species, and you might win a prize. Who knows? So yeah, follow us on Facebook, Instagram. Just keep up with us. And yeah, like we said, if you have anything interesting or exciting going on, we want to hear about it.
Definitely.
All right. Well, thank you so much.
Thanks, everyone.
Goodbye.
Bye.